so how do we find the area of this rectangle? Well, it's a 3 by 6 rectangle, so it's just 3 times 6, which is equal to 18. We could also break that 6 up into two other smaller rectangles. As you see, there are two squares here, so that's 3 by, let's not call them the same. Let's say one's 2 and one's 4. Will we get the same area? Is the area of these two rectangles together also 18? The answer is yes, it is, because we get 3 times 2 is 6, and 3 times 12 is 18. I'm sorry, 3 times 4 is 12, and 6 plus 12 is 18. So this is the same thing as saying 3 times 2 plus 3 times 4, which is also 18. And we could look at this as just really saying it's 3 times 2 plus 6. I'm sorry, 2 plus 4, which is also 18. So all these things are the same. So we, instead of multiplying directly, we could multiply each of the parts by 3. This is known as the distributive property. Alright, so in this case we were asked to find the area of this rectangle. Now, this isn't a number. I don't know how to multiply 3 by this thing altogether, but I do know how to multiply 3 by each of these things separately. 3 times 2x is 6x, and 3 times 3 is 9. So together, the area of this rectangle is 6x plus 9. In other words, if we were given this and asked to simplify this, in other words, to perform all addition, multiplication, subtraction, and division possible, we'd want to multiply this 3 by both of these terms, the first term and the second term. That's known as the distributive property. I'm going to distribute or multiply into every term inside the parentheses, because having 3 groups of this is the same thing as having 3 of each part and putting them all together. So 3 times 2x is 6x, and 3 times 3 is 9. If it's not clear why this is true, we could also think of this as 3 groups of 2x plus 3. If you add these all together, 2x plus 3 plus 2x plus 3 plus 2x plus 3. So the 2x plus the 2x plus the 2x is 6x, and the 3 plus 3 plus 3 is 9. So it's easier to use this distributive property. Alright, so we're going to look at a couple of examples. Hopefully this is clear what's happening. When you multiply by the all terms inside. So let's take a look at a couple of examples. Alright, so this is kind of the written version, that a times b plus c is equal to ab plus ac. All that really means is multiply each term on the inside by the term on the outer side. So this should be 3 times 2x, which is 6x, and 3 times 5, which is 15. Here we have negative 4 times 1x. Remember, it's 1, so that's negative 4x. And negative 4 times 8, which is negative 32. Here we have 3 terms, but it doesn't change. It's kind of like we have a rectangle with 3 parts, where this is 3, that's x squared, this is negative 3x, and this is 8. This will be 3x squared, this will be negative 9x, and that'll be 24. So this is 3x squared, this is negative 9x, and this is 24. Same terms. Okay. Now, this confuses people a lot, the negative on the outside of the parentheses. If there's no number, just like when it comes to the variables, then the number is 1. So if there's no number here, this is 1, and in this case this is really negative 1. So the negative in this case is negative 1. So this is the same thing as negative 2x minus 9, and this is just 3x plus 4. Alright, so that's from multiplying each term inside. Alright, so let's take a look at a few more examples. Alright, so these are a combination of different things. We're going to be combining like terms and distributing. Now, the order of operations says that multiplication comes before addition and subtraction, which is what combining like terms is, so we're going to distribute first. Alright, so we distribute here, we get 3x plus 12 minus 6x. Now, the like terms can be combined, but the non-like terms cannot. Okay? And based on the commutative property, we can move these next to each other if we want to rewrite it, but we could just combine the like terms. So 3x minus 6x is negative 3x. Let's try another example. In this case, again, it's tempting to want to add 2x and the 5 first, but these are not like terms. In addition to that, multiplication comes before addition, so we're going to work out the distributive property first. We almost always do the distributive property first. So this is 15x, and this is negative 40. We combine the like terms, which sometimes people like to put the like terms inside of the same symbol, because sometimes there's multiple groups of like terms. Like in that case, I'll put them in triangles. In this case, I'll put them in circles. So in this case, we have 2x plus 15x is equal to 17x minus 40. I don't really want to put equal signs because these aren't really equations. These are expressions. So this simplifies to this, which simplifies to that. Alright, in this one we have two distributions to do, but they are incredibly easy ones. 1 times anything is going to stay the same. Same thing here. That's still 9x, still 3y. Now to combine the like terms. These are the like terms. These are unlike terms. This one is kind of like its own term by itself, and so is this one. Okay, so that is 12x plus 3y, and what is it, 5? Okay, so this becomes that. Here, this one's a little more challenging. This is one that most people get wrong. Most students make mistakes on this particular example. Alright, it has to do with the negative here. Again, the negative means negative 1, and there's no number here, so it's like positive 1. So when we distribute the positive 1, everything stays the same. When we distribute the negative 1, everything changes. So let's combine the like terms, which there are a lot of them in this case, so we should really make sure we left out the square. That's very important. So the 2x squared and the negative 4x squared are like terms. Together they make negative 2x squared. The 3x and the 9x are like terms, and they make positive 12x. And the negative 4 and the negative 8 are like terms, and they make negative 12. Now I did purposely write these in a particular order, and that is the variable exponents are getting lower or descending as they go, because that's the convention that's normally used. You don't normally write things in a wacky order. You put them in some sort of organized manner, and we work with the exponents going down. Alright, in the previous example I had two different variables, and I kind of worked alphabetically. X comes before y, and then the lack of variable, the constant term, is usually on the end.